Hey guys, welcome to EduKaji. If you're first time here, allow me to introduce myself. My name is Walter and I'm a scientist as well as a chemistry tutor for the past 8 years.
All right, so this is the Johor trial paper for year 2021, and we'll be discussing the paper 1 version. So without further ado, let's move on to the questions. So the first question here asks you, based on diagram 1, shows a model of an atom, and then it asks you which of the following scientists actually introduced this model to you. So this is actually Donkey, all right, Ernest Rutherford. For number 2, diagram 2 shows a magnesium atom compared to the standard atom of carbon-12. Okay, so carbon-12 is actually the standard unit of atom to be used for comparison. So you can see over here that one atom of magnesium is balanced with 24 units. So I think pretty much you understand what it means already. And also in addition to that, if you look at the periodic table elements, you will notice that magnesium actually has a relative atomic mass of 24 also. So therefore, I'll say the answer here will be C. For number 3, an element has the following properties. It has high melting point, more than one oxidation number, good electrical conductivity, and forms colored compounds. I think a very distinct trait you can see over here will be having more than one oxidation number and also forms colored compounds. So these two characteristics is referring to transition element. Okay, so remember that transition elements have different properties compared to other metals. Okay, so therefore, look out for any of this which represents a transition element. Then we'll say that the only one here will be copper. So therefore, the answer here is supposed to be B. Number 4, diagram 3 shows the lattice structure of an ionic compound. Which substance is likely to have this kind of structure? So you have to see which of the question that the answer gives you is A, B, C only, right? And then you ask yourself which of those following actually have an ionic compound. So if you see properly, right, I would say that most likely it is A, magnesium oxide. Now, although some people may argue that aluminum chloride actually is a type of ionic compound, right? Supposedly you ever learned this before, but in your Form 6, if you were to attend Form 6 and takes advanced level chemistry, they will tell you that aluminum chloride actually is a ionic compound with some covalent properties. Okay, now let's just say we don't know that, and how can we actually tell if this structure is magnesium oxide or not? The formula of magnesium oxide is MgO, and the formula of aluminum chloride is AlCl3. All right. So in this case, you notice, right, for every the ratio, the ratio of magnesium to oxygen is 1:1, but the ratio between aluminum and chlorine is 1:3. So one would be able to see, most of us, right, if we take a look at the picture, you will notice that the number of atoms of the smaller one and the bigger one, right, it's about 1:1 ratio as well. All right, if not, then it'd be 1:3, means you will be likely to see a smaller atom having more of them on the picture itself, but you don't see that. You can see it's all just 1:1 ratio. So therefore, I'll say that this is more likely to be magnesium oxide compared to aluminum chloride. Okay, so that's my reasonable deduction to show you what I'm trying to say. So number 5, which of the following is a weak acid? So we know that hydrochloric acid is definitely wrong because it's a strong acid. Sulfuric acid also wrong. Ethanoic acid is supposed to be the answer. Okay. Nitric acid also wrong because these three, they are technically strong acids. For number 6, diagram 4 shows an energy profile diagram of an exothermic reaction. Okay, so they mentioned exothermic reaction. Which of the following is true about the diagram? So in this case here, you can see, right, this is AB, which represents the reactants. CD represents the products. EA is the activation energy, and the delta E technically is actually the delta H, which is the technically the what's it called, the heat of the reaction. So let's take a look and see. They ask you which one is true about diagram. So C and D are the reactants. I'll say this is wrong. This is actually on the right side. It's supposed to be the products. So therefore, A is out. A plus B are the products, also wrong. EA is the activation energy, correct. EA is heat absorbed, wrong. So answer is C. Yeah. Now, why is it not donkey? Because you see, right? Technically speaking, it's exothermic. So therefore, it must be releasing more heat than absorb. So therefore, C is donkey is out. 7, which of the following diagram shows the arrangement of particles in bronze? So bronze is an alloy, we'll say an alloy. So which of the following diagram shows you an alloy? The answer is D. Because it has a foreign particle inside, which actually disrupts the regular arrangement. So therefore, the best answer here to show there's a foreign atom inside, which disrupts the irregular pattern of the metal arrangement. So this is it. Number 8, what has happened to magnesium when burned in air? So when you burn magnesium in air, obviously magnesium here will gain oxygen, okay? But none of them actually point towards that. So I would say here, most likely it will be losing electron, right? Because why? You see here, magnesium, to form magnesium oxide, okay, it is supposed to be 2 Mg plus O2. You get 2 MgO, right? And the MgO over here is supposed to be, I'll say, an ionic compound. So magnesium, to form this compound, magnesium must donate 2 electrons away to oxygen, right? So I would say, in a very simple way to understand this, in order for magnesium to form an ion, magnesium must first release electrons. So it becomes Mg2 plus 2 electrons, right? And then after that, the oxide itself, the oxygen itself will receive the 2 electrons to form O2 minus, right? So therefore, because of this equation, this half equation over here, I will say that the answer is C, that magnesium has lost electron. Number 9, which of the following statement is true about alkynes? So alkyne is the hydrocarbon which contains triple bonds between the carbon atom. So does it dissolve in organic solvent? Yes, it's a hydrocarbon, it's a covalent compound, so it should be able to dissolve in organic solvent. Is it a saturated hydrocarbon? No, like I explained to you just now, it has a carbon-carbon triple bond, so therefore it is not saturated. It cannot conduct electricity. Very good, correct. It cannot because there's no ions moving. Has lower boiling point than alkene. No, it has triple bond. If you have a high boiling point. You imagine, right? Alkene has only carbon-carbon double bond. Alkynes has triple bond between carbon atoms. So you ask yourself, which one is more harder to break? Of course, it's going to be a triple bond, isn't it? So if it has a triple bond and it's harder to break, more heat is required to separate them. So therefore, we will say that definitely it will have a higher melting and boiling point compared to alkene. So the best answer here will be 1 and 3, and the answer is boy. Number 10, diagram 5 shows the energy level diagram for the reaction. So we have an exothermic reaction as well, because you see over here, it goes downwards, the arrow goes downwards, so that represents the exothermic reaction. And also the delta H value is actually negative. So it also proves to you that it is an exothermic reaction. So just keep in mind that this is actually supposed to be an exothermic reaction. So use that as a hint to answer your question. So what is the reaction between hydrochloric acid and sodium hydrogen carbonate? Or is it reaction between hydrochloric acid and also sodium carbonate? Or is it decomposition of zinc nitrate when heated, or dissolving ammonium nitrate in water? So I would say the best answer over here, supposedly, for this question over here, you have to be very strong in your thermochem to know all this. So the best answer here is actually B, okay? Not the one with hydrogen carbonate, but only the one with sodium carbonate, because this one is actually supposedly endothermic. And it's quite famous also. This question, they try to trick you. So remember, if you were to react acid with sodium with the hydrogen inside, it's an endothermic reaction. But if you remove the hydrogen and you take sodium carbonate, it suddenly becomes an exothermic. Okay. While the other two is actually endothermic as well. So the best answer here will be boil. That shows you the only exothermic reaction there. 11, which of the following is this side effect of mercury in the treatment of skin product? Mercury is known to be able to damage organs if it were to go into your bloodstream, and also causes nervous system damage. So I would say the best answer for number 11 here, which represents the closest one that's mentioned, will be damage to the kidney. I mean, kidney is an organ, so I did mention to you that it can actually cause organ damage if to sip into your bloodstream. So A with the best answer. 12, which of the following substance is a polymer? All right, so a polymer is made out of monomers, and the best one technically will be neoprene, isoprene, natural rubber. So I would say number 12 here, the answer is supposed to be B, neoprene actually, sorry. Neoprene is actually rubber. Isoprene is the monomer to the rubber. All right, so that's the easiest way to answer. Amino acid itself is a monomer, cannot be really, right? Tetrafluoroethene also is technically a monomer. So this is definitely out. So therefore, the answer is B. For 13, diagram 6 shows the cooling curve of liquid X, which of the following is correct? Physical state from T1, T2 is liquid and solid. T1, T2 is liquid and solid, then I say it's correct. Is it? Let me check and see. It says here cooling curve. Doesn't mention which one is the, whether it is a condensation or is a freezing. But I will assume that it is freezing, but I'm going to put this aside first. Attractive force between particles is overcome at T2. I will say no. Because it's cooling down, so it's not trying to overcome the force of attraction. It's actually building up the force itself to pull to pull the atoms closer to each other, or the particles close to each other. And at C, all particles vibrate at T1. I'll say no. They haven't changed to solid yet. So definitely it won't be able to vibrate. It will still be able to move freely and randomly. Is the freezing point Y? No, the freezing point is at X, because it takes time for the particles to release the heat and also to allow the force of attraction to pull them close to each other. So it's actually X itself is the freezing point. So this is wrong. So therefore, the first answer is actually correct, because the physical state between here and here is supposed to be liquid plus solid. Correct. 14, which of the following compound hydrogen bond does not exist? So remember, hydrogen bond is between F, O, and N, which sounds like handphone. All right, so if it's handphone means you must remember any molecule which has hydrogen, and the adjacent molecule must be able to have fluorine, oxygen, and nitrogen in this way. So then it must be either things like hydrogen fluoride between hydrogen fluoride, or then you have things like water, or you have things like what else we have, ammonia. Then you'll be able to form hydrogen bonding with the adjacent molecules. Okay, so among all of this, I already mentioned all three. This one can form hydrogen bond. So therefore, this one cannot. Now, why is that cannot? Because if you see a HCl with another HCl, this one over here is not H to F, H to O, H to N. To form hydrogen bond, the adjacent molecule must have this combo. Then you'll be able to have it. But because this is not, so we consider this as van der Waals forces. Okay, so that's the answer. Number 14 is supposed to be donkey, which does not have the hydrogen bond. 15, diagram 7 shows the use of apparatus X in an experiment. What is a suitable type of glass to make apparatus X? So the one that we use labware normally in the laboratory setting, right? We'll use something which is chemically resistant and also heat resistant, because we have to put chemicals inside and we have to boil it sometimes. So therefore, the answer here will be borosilicate class, which is the stronger type. Always remember, labware, cookingware, we will always use borosilicate class, which is stronger and better. 16, diagram 8 shows the natural water cycle. So X is the evaporation of water into the air to be condensed in the cloud. So process X cannot be freezing. So these two is out. It's not boiling either. It's because the evaporation of water occurs on the surface of the water only. You don't see bubbles forming in the ocean. All right, and it comes up. So no boiling. Boiling requires a lot of energy. And if you're wondering, the sun is baking up or the sun is heating up the water and allow it to boil, no, it doesn't. Then all the fish will die technically. So in this case, it's most likely referring to evaporation, although heat is being involved from the sun, but the heat is not enough to boil the water. What it does is that it increases the kinetic energy perhaps, and then evaporation will happen faster. Yes, correct, but it's not boiling. Okay, so in this case right now, if you realize condensation is not it also, so the only answer here possible, which is A, evaporation, and the energy change is that it is absorbing heat. 17, element Y is located on the right of the periodic table elements. Which of the following combination shows the correct property of oxide of Y? So it says here on the right side of the periodic table. All right, we know that going from left to right, it is basically basic oxide to M4 ferric oxide, and then finally to the acidic oxide. So I would say most likely it is a non-metal, okay, and it is acidic in nature. So therefore, the answer here will be donkey. Number 18, diagram 9 shows the structure and the boiling points of ethanol and water, which are commonly used as a solvent. So we have here, which is ethanol and then water. One is 78 degrees Celsius and one is 100 degrees Celsius in terms of their boiling point. So which of the following statement is most accurately explaining the difference in the boiling points of water and ethanol? So let's just take a look. Intermolecular force of attraction between water are stronger than between ethanol molecules. So actually we see both also has, what's it called? Both also technically has, what's it called? Hydrogen bonding, sorry, okay? Hydrogen bonding. So therefore, you must keep that in mind. But intermolecular forces increases with the, what's it called? Intermolecular forces increases with its, I lost the word. But anyway, so we are explaining in terms of the bond between hydrogen of what's it called, of the ethanol and also the water. But in this case, what happens is that water itself has a higher boiling point and compared to ethanol, right? So we will, of course, we will say that the intermolecular force is stronger in the water compared to ethanol. If not, then why would there need extra amount of heat energy to separate them, isn't it? So therefore, we'll say that A is the best answer in this case. Okay, well, the rest is actually not true. All right, if you were to look at the both of it, right, you can see that they are actually mentioning the covalent bonds, but we all definitely know that it is nothing to do with covalent bonds because we're not breaking the covalent bonds. The covalent bonds is inside over here. We're not breaking the covalent bonds. We are breaking the one in between the molecules. In this case, it's hydrogen bond. Okay, you understand? So therefore, we will say that water has a stronger intermolecular forces between themselves compared to ethanol molecules. 19, diagram 10 shows a blast furnace and its temperature during extraction of iron ore. Right, and you have material X in the outside. So what's the property of material X and make it suitable to be used as the lining of the blast furnace? So the blast furnace inside is really, really, really hot. All right, very high temperature. So what is the material that we need to use? Of course, something which is of a heat insulator, okay? So of course, some will say, oh, it must be hard and strong, isn't it? Because there's a lot of things inside. Yes, in a way. But remember, inside the blast furnace is very hot. So if you don't use something which is of a heat insulator, it will not be able to withstand the heat. And what happens is that it will start to technically, I'll say, break apart. It'll melt in a way, right? So heat insulator is the #1 choice in terms of materials to look out for. 2011 shows the structural formula of a carbon compound. This is actually a 4-carbon alkene with the alkyl group on top over here. So how do we, name these compounds? We got one. This is carbon number, the carbon number 1, carbon number 2, 3, and 4. So the alkyl group is a 1 alkyl group. 1 carbon alkyl group. So this is a methyl. So the methyl group is actually attached towards carbon number 2, and the double bond is also at carbon number 2. So we'll call this as 2-methyl but 2-ene. Right? 2-methyl but 2-ene. The answer is cat. 21, which of the following statement is true about endothermic reaction? All right, so the best answer to describe an endothermic reaction is, let's take a look at the first one. Heat absorbed in breaking bond is equal to heat release in the bond formation. It cannot be equal. A is out. Why? If your heat absorbed and your heat release is equal, then your delta H is 0. Your heat change is 0. How is it possible? If it's 0, then how can there be a value anymore, right? And there's no endo, there's no exo. It's just like now, room temperature. So therefore, it's wrong. Total energy content of the reactant is higher than the total energy of the products. No, that is for exothermic, okay? B is for exothermic reaction. Endothermic reaction, you will see that the particles of the products will have a higher energy compared to the reactants, okay? So you see over here, C, a little heat is absorbed or released in bond breaking and bond formation. I don't understand what that means. This looks a little bit weird. So a little heat. This little heat actually confuses people. I would say the little heat here, it's not how you quantify, heat of a particular reaction. So most likely, that's not the answer really, because we don't use such a non-technical term in science. So this is out. For D, heat absorbed in bond breaking is higher than heat release is correct. When your heat absorbed is higher than the heat release, then overall there'll be more heat absorbed compared to heat release. Temperature will remain low. So that's the best answer to describe an endothermic reaction. 21 is donkey. 22, table 1 shows the results of experiment to investigate property of rubber. So we have vulcanized rubber and unvulcanized rubber. You actually try to stretch it and you see how long it stretch and whether it is still able to go back to its original shape or not after that. All right, so based on this particular table with all the information that you have, it's asking you which of the following statement is actually true. All right, so we will say that vulcanized rubber is less resistant to heat than unvulcanized rubber. I don't think we are applying any heat at all, so I don't think this is the factor that we are investigating. All right, and then next one will be vulcanized rubber oxidizes more easily. I don't think that's also that. Vulcanized rubber is softer than unvulcanized rubber, also not relevant. It's not about stretching it, right? You can see it stretches. So we're actually testing the elasticity of the rubber instead. So since this is indicating elasticity, that the vulcanized rubber is more elastic than unvulcanized rubber, so I would say it is technically correct. So therefore, number 22 is donkey. 23, diagram 12 shows a smartphone battery which is made of material Q. All right, if you see properly, that is most likely referring to graphene. All right, now how to differentiate between graphene and graphite? Very easy, yeah? Now, how do I know if it's graphene or graphite? But I'll explain to you, okay? So you know the structure of the graphite, isn't it? Graphite has this hexagonal ring structure. Well, it is still considered as a macromolecular structure because it has many carbon atoms covalently bonded together. But unlike diamond, what happens here is that supposedly, yeah, inside this structure of graphite, they have different layers, all right, that's stacked up together. And when that happens, supposedly between the layers, there is a weaker van der Waals forces between the carbon atoms. You know what I mean? So therefore, what happens here is that if you take this whole structure with that intermolecular force, that's called graphite. But if you take out one layer only, one layer, not the whole set, just one layer, and you take it out, that one layer is called graphene. So again, one layer is called graphene, and the whole structure by itself, that's called graphite. Okay, the whole structure by itself is called graphite. So it's a different story. So this is just one layer that's placed in the battery. So please don't get confused, I would say. So for number 23 over here is referring to graphene, not graphite. So be very careful with that. Not diamond, not fluorine as well. Okay, now how do I know if it's graphite or graphene? You can see here every single carbon atom is bonded to another 3 carbon atoms only. So the whole thing itself has a delocalized electron inside to conduct electricity. Okay, so the answer here will be boy. 24, diagram 13 shows the apparatus cell to determine the empirical formula of magnesium oxide. Which of the following steps is correct to ensure that the magnesium ribbon reacts with oxygen and burn completely? So normally what we do is that to make sure that it reacts completely, we have to open and close the lid, all right, constantly in intervals. One thing is that we want to open and close because we want to prevent the white color fumes from coming out from the magnesium oxide powder that flies around because of the heat. So another one is actually to take the whole crucible with the magnesium oxide and try to weigh it repeatedly, right, again and again, to make sure that it has this constant mass. Once you achieve that constant mass, it'll technically be complete already, the reaction. So the best situation to describe these two, I mean, this whole experiment, okay, is actually 1 and 2, okay? Repeat the process of heating, cooling, and weighing until the mass is constant, and then heat the magnesium ribbon strongly in the crucible without its lid. Sorry, my bad. Actually, you're right. No, 2 is not. I'll say 1 and 4, actually. Yeah, answer is supposed to be 1 and 4, not 1 and 2. Because you see, without its lid, then of course like I said, the powder will fly around. Okay, the marking scheme actually wrote 1 and 2 is A. Supposedly, if you check the marking scheme, it's actually wrong though. You cannot open up the lid. If you guys have done an experiment before, you understand what I mean, right? The white color fumes of magnesium oxide just fly around. So remember, this is actually no answer. I think there's a mistake that they done. It's supposed to be 1 and 4 though. So I'm gonna write it over here just so you guys know. It's supposed to be 1 and 4. So 1 and 4. No answer. So therefore, I'll just put here number 24. No answer. Okay. Yeah. All right. 25. Which of the following materials produced from condensation polymerization? Terylene apparently is from condensation polymerization. So the rest of it is not. Like you see, polyethylene is addition polymerization. Polystyrene is also addition polymerization. Natural rubber also, because they all have carbon-carbon double bonds. Okay, so terylene is different because you have to remove off some atoms before you form new bonds. So that's called condensation polymerization. Other than that, all addition polymerization. 26, a student carried out 2 experiments to investigate the rate of decomposition of 0.1 mole per dm cube of hydrogen peroxide. Table 2 shows the apparatus set up to carry out the experiment. All right, so we have a gas syringe used to actually take, to measure the amount of gas release. And then for the second experiment, okay, the first experiment, no added substances, but second one, you actually add an extra manganese 4 oxide powder, which can actually serve as a catalyst to increase the rate of reaction. So you can see here, the time taken for experiment 2 is shorter than experiment 1. What is the function of the manganese 4 oxide in the experiment 2? So as I said just now, it is actually used as a catalyst. And what does it actually do? It actually provides an alternative route with a lower activation energy so that the reaction can proceed forward easily. Okay, so the answer here will be C. 27, the following ionic equation represents a redox reaction, zinc plus copper 2 plus, and then zinc 2 plus plus copper. So this is a displacement reaction, I would say. So which reaction can be represented by giving the ionic equation? Let's see. I would say donkey, because zinc is more electropositive than copper. So it has a more negative standard electropotential value compared to copper. So if you were to put a more electropositive metal into a salt solution with a less electropositive metal, that particular more electropositive metal, such as zinc, will be able to displace copper out from its own salt, right? So when you actually drop in the zinc strip into copper to nitrate, supposedly what will happen, it will be that zinc itself will react with copper to sulfate, and what you'll get is zinc sulfate plus copper, right? So therefore, this is considered as a what's it called? It is considered as a redox reaction. All right, 28. 14 shows the elements of W, X, Y, and Z in the periodic table of elements, all scattered around. So which of the following is the statement is correct? So W and Z form ions with charge -1. So W is, Z cannot, because Z here is group 18 element, so it's a noble gas. So I'll say here Z do not form a -1 ion. A is out. Atomic size of X is larger than Y. No, because you see here X is in period 3 and Y is period 4. So we know that Y has 4 electron shells while X has 3 electron shells. So definitely Y will be larger than X. So B is out as well. Y and Z have the same number of shells occupied with electrons. So Y and Z is all both located in period 4. So the answer is correct. Yes, it indeed has 4 shells occupied with electrons. Donkey is the most likely wrong. X has 3 more electrons than W in outermost shell. No. Okay, it's quite far away from W, so I don't think it is the answer. So therefore, the answer is C. 29, diagram 15 shows the cross-section and pattern of Damascus steel sword, which hardness is famously known. All right. So which of the following is correct about its hardness or its properties? Referring to this, right, they're actually talking about the steel sword. So steel is their main point. There's an alloy. So the alloy will cause the particular metal to become harder and stronger. So why is that so? It's because of the foreign atoms being able to disrupt the orderly arrangement of pure atoms. So when you use an alloy to hit against the surface, it will not bend, it will not break that easily compared to using pure metals, which are more flimsy because they can bend very well, as we call them as being malleable and ductile. 30. Rudy has washed his clothes using water from the well, but the dirt is still there. So which of the following statements most accurately describe the situation? Now, we talk about, they didn't actually mention a lot of details, because you see, right, supposedly they're supposed to tell you that Rudy washed the clothes with a soap or detergent, but they didn't. They just say Rudy washed the clothes only with water. So how am I supposed to know whether the soap is not there? Supposedly we should say that, oh, there's no soap there, but you can't use that. So I think what question 30 is implying is that Rudy was actually using soap to wash the clothes, but because there is, in the well itself is hard water, it contains calcium, magnesium ions. So assuming that is the case, then of course the answer is supposed to be A lah. But there's no soap, like I said, right? There's no soap, so we cannot simply just assume, I would say. It's very hard to tell, but can we just assume that it is soap? Okay, let's just assume that it's soap, okay? Because the question is somehow quite incomplete. So therefore, I'll say that it is actually A lah, okay? Assuming that the well has hard water and soap can form scums, right? So it won't be able to cleanse the baju or the clothes properly. So therefore, the stain will still be there, all right? So the answer is A. All right, 31. We have X consists of two isotopes, chlorine. Sorry, not chlorine. It says X, but it's supposed to be chlorine. All right, X consists of two isotopes, X35, X37. The natural abundance of X35 is 75%, and X37 is 25%. Calculate the relative atomic mass of X. So very simple. All you have to do is just to do this. All right, relative atomic mass. On average, if you take account all isotopes, you just have to take the mass of isotope X, multiply by its relative abundance, and then same thing happens for the X37. I keep saying chlorine because I know it's chlorine, sorry. And then you just multiply by the relative abundance. All right, and then you draw a straight line across and then divide it by 100. You're supposed to get 35.5 as the RAM. So the answer for number 31 is technically Boyd. All right, and then 32, what's the percentage composition of water by mass in hydrated iron 3 sulfate FeSO4.7H2O? All right, now we're going to take water's mass only, yeah? So water's mass. So we're going to calculate molar mass of water. So molar mass is also known as the relative molecular mass. It doesn't matter, okay? So molar mass of H2O is supposed to be, 2 plus 16. So it's 18 grams per mole. And then now what we're going to do is we're going to calculate and see, 7H2O is how much. And then we'll take the 7H2O's mass, divide by the total mass of the whole thing, and multiply by 1000. Okay. So right now we have 18 for water. And then let's take a look at the molar mass of FeSO4.7H2O. So let me just calculate that very quickly. It should be correct. So total mass of this will be 278 grams per mole. All right, and then you have to get the mass of the 7 moles of water. So that'd be 7 times 18. So it's 126 grams per mole. All right, now to get the composition, percentage of composition of water by mass in the hydrated salt. We just have to take 126 divide by 278 multiply by 100. And the answer here will be, sorry, click wrongly. %45.32%. So answer is C. Right, very easy. So you can use this for any compound or elements that's inside a compound, so can. So this is the way they calculate percentage by mass. All right, 33. The student required to prepare barium sulfate in a salt laboratory. Which of the following chemical equations are suitable to prepare the salt? Now, before that, let me just remind you that barium sulfate is actually an insoluble salt. So you will need soluble barium to be present to conduct double decomposition method to produce this salt. Now you can actually use barium nitrate because barium nitrate is soluble. All nitrates are soluble. Okay, but you can't use barium carbonate in this case. So we have one which is correct. You can use the first one. Oh, but wait again. Then again, zinc sulfate. So I'll say you must remember that both sides of the equation, both of the reactants must be soluble in a way, I would say. Okay. So in this case over here, I would say the first one can, no problem. Second one cannot because BaCO3 is not soluble. Okay, BaCl2 plus K2SO4 also can because barium chloride is soluble. And barium hydroxide is not soluble, so cannot be used also. So the best answer here will be 1 and 3. Boy, yeah. So soluble salt, insoluble salt, soluble salt, soluble salt, soluble salt, insoluble salt, soluble salt. That's what we call it as double decomposition. Okay. 34, table 3 shows the mass of sulfur trioxide formed at different temperatures during contact process within 150 minutes. Which of the following temperature produce the highest rate of reaction? So we'll see, of course, when we talk about highest rate of reaction, it doesn't concern whether we have a highest yield or not. Okay, they're asking you not the highest yield because most of us will get very confused and say, oh, you see, if I go to 600, we get the lowest mass. So I should take the highest mass one as my preferred temperature. No. All right, the question says nothing about yields, asking you about rate of reaction. So based on rate of reaction, the higher the temperature, okay, the higher the temperature, the higher the rate of reaction. Okay, so you can see here, table 3 shows the mass of sulfur trioxide formed at different temperatures during contact process within 150 minutes. But they're asking you which of the following temperature produces the highest rate of reaction, not the highest yield. It's a tricky question actually. Okay, so highest rate of reaction will technically be 600. The higher temperature, the higher the rate of reaction. But because supposedly, all right, this is not taught in your SPM level, I'm supposed to let you know. Okay, sulfur dioxide plus oxygen, you have a reversible reaction to produce 2 moles of sulfur trioxide. So you have a reversible arrow here, which actually what we call as the, we'll say that it's actually a dynamic equilibrium. Okay, so any kind of disturbance towards the system in the equilibrium, according to Le Chatelier's principle, supposedly it will shift to a position where there's either increase or decrease of the yield of sulfur trioxide. Okay, so we see what we see here is the mass of sulfur trioxide formed is actually the yield. Of course, the yield wise will be lower, which we don't want. But then again, we say, right, based on temperature, the higher the better in terms of the rate of reaction. So be very careful. It's a bit tricky over here. So the answer here is supposed to be donkey. All right. Unless they say highest yield or highest mass of sulfur trioxide produced, then it's a different story. All right, 35. Which of the following equation represents the redox reaction? So you have to check on by one and see which one is redox. You can talk about the gain or loss in oxygen. If you were to do that, you realize there's only one answer over there. Okay, so the answer here is supposed to be donkey. Why? Because you see here, carbon gains the oxygen to form carbon dioxide, and copper loses the oxygen to form copper. Very straightforward. The rest of it, you can see properly, the charges of each and every ion does not change. All of them, A, B, C. But only D here has fulfilled one of the redox definition. And the answer here is supposed to be 2CO2 plus C, you get still 2Cu plus CO2. So we'll say that copper has lost its oxygen, undergoes reduction, and carbon has gained an oxygen, so it undergoes oxidation process. So therefore, answer is donkey. 36. When 50 cm cube of 2.0 mole per dm cube of lead 2 nitrate was added to 50 cm cube of 2.0 mole per dm cube of sodium sulfate, temperature increased by 10 degrees Celsius. What is the value of heat of precipitation? Okay, so we want to get all the information that we need. We are adding 50 to 50. Temperature increased by 10. So we'll start with calculating Q is equivalent to MC theta. M will be 100 because my total volume of solution is 100. And then after that, my C is 4.2. Sorry, this is not plus, it's supposed to be multiply. Okay, so we got 4.2 multiplied by the change in temperature, which is 10. So 100 times 4.2 times 10. You get 4,200 joules, which I'm going to convert to kilojoules because it's easier to get your delta H requirement. Next, delta H is equivalent to Q over N, okay? So since the concentration and also the volume is the same, so we're going to use either one of it to calculate N. So N is MV for 1,000, and that will be 2 times 50 divided by 1,000. So that would be supposedly 0.1, but I don't trust myself, so I'm just going to use the calculator right now. Okay. You have to be more careful. Huh? So 100 divided by 1,000 will be 0.1, correct? So right now, can just substitute these two values in, 4.2 and 0.1. So 4.2 kilojoules divided by 0.1 mole. So you will get 42, negative 42 kilojoules per mole. Negative because it says here temperature increase, which indicates an exothermic reaction. Exothermic reaction means negative delta H value. So the answer is C. 37. Which vehicle tires are among the products of synthetic rubber that need to be disposed of in large quantities? Unsustainable disposal of tire results in environmental pollution. Which of the following is the best method to reduce issue of environmental pollution? So I'll say number 37 here. The best answer to describe there will definitely be A. Right? Tires can be reused or recycled. The rest of it doesn't make sense based on logical reasoning. 38. The following equation shows the complete combustion of propene gas. Okay, what is the mass of water produced when 2.1 grams of propene gas is burned completely? So you can see here in terms of number of mole, 2 moles react with 9 moles to give you 6 moles and 6 moles, right? So we're going to see how many moles of propene is that in 2.1 grams. So we'll start off with calculating the molar mass, all right, of propene. So that would be 3 times 12 plus 6 times 1. So total is 42 grams per mole. All right, and then now we got 2.1, right? So let's calculate number of mole first. So number of mole of C3H6 will be 2.1 divided by 42. So that would be 0.05 mole. All right. So they'll ask you to calculate the mass of water. So now the water, right, in terms of ratio, it's 2 to 6. I would say if you were to make it in a simplified form, I would say it is 1 to 3, correct? Divide all by 2, you get 1 to 3. So if there is 0.05 mole of propene, then this side will have 0.15 times 3. Okay, times 3, and you will get 0.15 mole. Okay, so right now, number of mole of water is 0.15. Then after that, you calculate the molar mass of water. Okay, so it's 2 plus 16, 18 grams per mole. So the mass of water produced in this reaction will be 0.15 mole multiplied by 18 grams per mole. The answer is 2.7 grams in total. The answer is boy. Right? Let's compare in ratios and you get the answer correctly. 39. Qualitative analysis of salt is a technique used to identify the cation and anion present in a salt. Diagram 16 shows a flow chart of the qualitative analysis of X. So X, after that, it became, after heating up, the residue is yellow when hot, white when cold. So this is definitely referring to zinc already, zinc oxide. This is a distinct trait of zinc oxide. And then there's nitrogen dioxide and oxygen. Then plus HCl, you get salt solution of Y. So they want you to ask and see what is being present. So I would say that if you have nitrogen dioxide and oxygen, then this will be technically zinc nitrate already. Okay, because zinc nitrate will decompose when you heat it up to produce zinc oxide and also NO2 and O2. Then ZnO is actually basic oxide, so it will react with, actually it's amphoteric, no, it's basic oxide. So it will react with HCl to get you something else, which is ZnCl2. Okay, so right now they're asking you for a reagent to use to test the presence of cation and anion in the salt solution Y, which is this one. So to test for Zn2 plus and also Cl minus, the best possible one will be Zn will be either ammonia or sodium hydroxide solution. But to test for the chloride ion, you can actually just use silver nitrate solution. Okay, so once you get your silver nitrate solution, you test it, you'll be able to get what's it called? You'll be able to get a precipitate being formed because silver chloride is insoluble. So the best answer to describe these two tests here will be definitely C. Okay, why? Because zinc, what's it called? Zinc ions can dissolve inside. I mean, zinc ions can form precipitate with hydroxide ion that's provided by sodium hydroxide, but it will then dissolve again because it is soluble in excess sodium hydroxide. And then for the next one, for anion, silver nitrate, you mix it together with zinc chloride, you'll form silver chloride to give you a white color precipitate. So C is the answer. And last question, number 40, table 4 shows the chemical reactions and its observations. So the first one you see over here, hydrogen sulfide is added with chlorine gas and then yellow solid is formed. Chlorine water is added to potassium hydroiodide solution and you get a colorless solution turns brown. So which of the following statements is true about hydrogen sulfide and chlorine water? So very obviously this one over here, it turns brown because of iodine. Why? Is because chlorine is more reactive than iodine. So it's able to displace iodine out from its own solution. All right. And also because in this case over here, chlorine receives the electron and iodide is the one that releases the electrons out. So we'll say that iodide ions are actually oxidized while chlorine actually reduced. So it's a redox reaction also. Okay, and after that, for the other one, hydrogen sulfide and chlorine gas also something similar. You see a white color solid form. So the best answer here would be, because they are both redox reaction, you just have to see what happens to the both substances inside there. So the best answer to describe the situation over here will actually be donkey, because I told you it's not right. Chlorine undergoes reduction process to form chloride ions, and hydrogen sulfide here also same thing. It is actually losing the hydrogen, right? From hydrogen sulfide, it actually forms a yellow solid, and this indicates sulfur. So it loses the hydrogen, so it's being actually oxidized in a way. So therefore, the answer is donkey. Okay, so the reason is very simple. S loses hydrogen, So it's oxidation. And then this one over here, Cl 2 receives electron to form 2 Cl minus. Okay, to form 2 done. So that's the idea behind it. All right, so this is the end of the paper. So I hope you guys will be able to use this to do your revision and also to be able to gain some knowledge when it comes to different chapters across your syllabus. That's all for me today. I hope you guys will see you guys in the next video.